Welcome back to AK App Logics. In the previous videos, I have discussed about the Verilog and Python and C++, some of the languages. So from today onwards, we are going to start a new series. We are going to start a new series that is based on the VHDL language. It is also similar language to the Verilog, okay, which is a hardware description language. So this is connecting by the AK App Logics channel. So if you haven't subscribed at the channel, you must subscribe the channel. Then only you can able to learn the content quickly. Whenever I upload the video, you will get a notified faster. Yeah, so that you must subscribe and click the bell icon. And also I will provide certifications for the uh, people who have completed this course. You just message in the comment. Okay, yeah. So without any delay, let's go into the introduction of the VHDL. So to know to if you want to understand this VHDL, you should have a basic knowledge uh, about the DE. Okay, DE means digital electronics. You should have some basic knowledge about DE. Okay, what we are going to do with this VHDL and Verilog hardware description language, basically we are going to describe the hardware. Okay, we are going to describe the hardware in the code format. So for that we are going to use this type of languages which are known as HDL languages. There are two types of HDL language. One is VHDL and Verilog, you know, right? So if you haven't know, just watch these videos, then you can able to understand very goodly. But the prerequisite of this course is DE. Okay, it's very important to understand this course. Next, coming to introduction to VHDL. VHDL stands for VHSIC HDL. Okay, VHSIC HDL. Let me change the spelling. Okay, VHSIC HDL. Okay, what is this full form? Okay, let's see. VHSI means very high speed integrated circuit hardware description language. Okay, the full form of this is very high speed integrated circuit hardware description language. Hardware description language means we are going to describe the hardware, right? Like we are going to describe the half adder, full adder, AND gates, multiplexers using the coding, right? For that we are going to use the VHDL. So it is called as very high speed integrated circuit language. Okay, it consists of entity and architecture. It consists of entity and architecture. Okay, so in the Verilog we have seen that in the Verilog we can observe that we it consists of modules, right? Like that, module and module, right? Like this. In this VHDL we have two types, right? One is entity and other is architecture. Okay, it's not two types. A VHDL program will contain these two in it. Coming to Verilog HDL, this is also one type of hardware description language which is used to describe the hardware, like the components in the digital electronics, like half adder, full adder, all this. Okay, so VHDL is a strongly typed language. It means we need to use more syntactical part. Okay, there is more part of code. Okay, it is very difficult to write the code in VHDL. So in Verilog we can write the code very simply. Okay, the syntax of Verilog is also similar to the C, whereas VHDL the syntax is similar to Ada, Pascal, those languages. Okay, if you use those languages, those languages are only restricted to learn the VHDL, right? So but if you run C language, then you can able to learn the VHDL Verilog HDL very quickly. Okay, Verilog HDL, in that Verilog means verification plus logic. It means we are going to design the code design the it means we are going to design the code, right? We are going to write the code for the half adder. For suppose if you are going to write the code for the half adder, then you must verify it whether it is working as half adder or any other circuit only. To it means you need to check its functionality. Okay, by giving some inputs to it. Okay, how we are going to give inputs? By whether It depends upon the software, whether some softwares allow us to give inputs manually, like Xilinx Vivado, we can give that manually. Okay, but most of the softwares allow us to most of the softwares wanted us to write the test bench. Okay, the test bench is used to apply the input. We shouldn't call them as inputs, we should call them as input vectors. Okay. Okay. After designing the code of the certain design, then we are going to write another code which is a test bench. It means it will contain the test vectors. These test vectors will be applied to the design which we have designed, and we will observe the corresponding output. Okay, and we will have a reference. What is our reference? That's the truth table itself. Okay, we will compare the both reference and the output that we got. Okay, and we will compare and we'll check the functionality of the design. If the every output matches with the reference output, then we can able to say that our design is 100% working. There is no any errors in it. Okay, yeah. So it means, so that only we will call that as verification plus logic. Okay, it means logic means designing the code for the circuit, whereas verification means for that designed circuit we are going to apply the input test vectors using TB or manually. In Xilinx Vivado it will be manual, and also uh, TB also we can write in it. Yeah, next. It consists of modules, right? You already seen it, right? It consists of modules and end module. Okay, in between module and end module we are going to write our code. Okay, whereas in VHDL it has entity and architecture. Okay, it means a VHDL program consists of both entity and architecture. Okay, what is this entity and architecture we will going to see now. Okay, don't worry. Next, VHDL. Suppose if we are going to take the AND gate. Okay, we will write the expression of AND gate like a y equal to less than or equal to a and b. Okay, where this and is a keyword. Okay, this particular and is a keyboard. Okay, like this we will write the code format of this circuit. This is AND gate, which is a circuit in the digital electronics. We are going to write in the code format like this in VHDL. Okay, this is one shell. This tail is data flow. Okay, yeah. Where this and is a keyword. Okay, where this less than or equal to is a assignment uh, operator. Okay, this is assignment operator, less than or equal to. Okay, it consists of two parts. Okay, VHDL code consists of two parts. One is entity, right? We already seen in the previous slide. Entity, it will define the inputs and outputs and generic variables. Okay, for example, if you are going to take this particular AND gate, so what are the inputs to this AND gate is A and B, right? Okay, and what is the output is the y. Okay, defining or the declaring of those inputs and outputs will be done in the entity, in the VHDL programming part. Okay, and also what is meant by generic variables. Okay, generic variables means it's simply like constants. Okay, so in some programs we need to use some constant values. Okay, okay, for example, if you are going to take the UART. Okay, UART, in that we will use baud rates, right? Baud rate will be used as 9600, right? It is a constant value, right? For giving for declaring this type of constant values like baud rate generator or any, like if you want to design parameterized designs. Okay, parameter designs means it will be work for any bit value. For example, if you're having a 4-bit triple carry adder. Okay, if it we have a 4-bit triple carry adder, it means it will works for only 4-bit, right? If you want to make it for the 32-bit, then what you will do, you will just instantiate this particular 4-bit full adder, 4-bit triple carry adder several number of times, and you will get the 32-bit triple carry adder. So like this you have to do some changes, right? So without doing those changes you can write a generalized code. Okay, for to make it working for any bit triple carry adder, so that you will take a variable n. okay, and you will assign some value. If your requirement is 32-bit, then you will assign it to the 32. If your requirement is 4-bit triple carrier, then you will assign n with 4. If your requirement is 16-bit triple carrier, then you will assign with it with 16. Okay, so it means you can change, right? Simply you can change this place value, then the particular code will be worked as n bit triple carry adder. So where this n is a generic variable, why? Because it's a constant. Okay, it's a constant. So in this case also we can use, one is we can use in the case of baud rate generator, in the UART we can specify 9600. Okay, and also if you want to make your designs parameterized designs, then you can use these generic variables. Generic variables means you simply remember it as a constant. Okay, constant value throughout the program. Okay, next, and the second part of the VHDL code is architecture. Architecture means it is description of the relation between inputs and outputs. Okay, in the entity, what we are going to do, we are going to specify what are the inputs, what are the outputs, what are the generic variables, and all those stuff. We are not going to specify any relation between inputs, outputs, and generic variables in the entity itself. Okay, in the architecture, what we are going to do, we are going to specify that particular relation between the inputs and outputs and any generic variables. Okay, so we are not going to again declare the inputs and outputs in the architecture. Why? Because we already declared those in the entity. Okay, combination of these two, it means entity plus architecture will gives you the complete VHDL design code. Okay, so that's it. In the coming slides, let us see also in deep. Yeah. Entity declaration. Okay, now what we have done is, first of all we know that VHDL program is contain two parts. One is entity and another is architecture. Entity is consisting of inputs and outputs and any generic variables declarations. In the architecture, what it contain, it will contain the relation between them, relation between the inputs and outputs and any generic variables. Now let's see them in deep. Entity declaration, external view of logical circuit. Okay, for example, if I'm going to take the and gate. Okay, so what in the external view means outside this circuit we can see the inputs and the outputs, right? What are the inputs? A and B are the inputs and Y is the output. Okay, to specify these inputs and outputs in the code, what we have to use is entity. Okay, so it will describe the input output ports. These things will be called as ports, input port and output port. It will call as input port and output port. For example, port. Okay, this is port which is output port. This is output port. Sorry, my handwriting is little bit clumsy. This is input port. Okay, so we are having two inputs and one output port. Okay, so describing the input ports of the logical module or circuit. Okay, and provides external view of the component. Okay, what we are going to get from the entity, we are going to get the external view, right? The inputs and outputs are external to the circuit, right? So that's why we are going to say it as a external view of the component. Okay, next, syntax for the entity. Okay, syntax for the entity. Entity is a keyword, and entity name, we can specify any name to the entity. Okay, whether it may be the AND gate. AND gate we can give, we shouldn't give AND. Why? Because in the previous slide we have seen, right, AND is a keyword, so we shouldn't use it as entity name. Okay, because it has some specific name in it. Okay, so that we shouldn't use it. Next, is also a keyword. Okay, is also a keyword. It means, what is meant by keyword means it is predefined. Okay, it is just syntax, we should remember it. Okay, next, generic declaration. Generic declaration means, I already told you, right, what is meant by generic declarations. Generic declaration means any constant values declarations. Constant value declarations. Constant. Okay, like we are going to do you in your baud rate generator. Okay, we are going to use the 9600 constant value, and also to make any design parameterized design, then we are going to use this Generic declarations. Next, port class in the sense, what is meant by ports I already told you, right? Input and output. Port class means declaring those inputs and outputs. Okay, simply declaring those inputs and output ports. Port class. Okay, what is meant by port I already told you. Both inputs and outputs will be called as ports. Input port and output port. Declaring those input and output ports in the entity, okay, is called port class. Okay, next, entity declarative items. Okay, entity declarative items, this will be discussed by me when it arrives. Okay, don't forget. Okay, and is a keyword, and entity name. Okay, entity name, semicolon, you must write semicolon over here. In the Verilog we shouldn't write and after end module we shouldn't write semicolon, but in the VHDL we must write after end entity name we should give semicolon. Don't forget it. Okay, entity name is user defined. Okay, is a keyword and entity is a keyword. Okay, here. Okay, yeah, now let us see each of these. Okay, what is meant by generic declaration in deep, and what is meant by port class in deep, what is meant by entity declarative items in deep. Before that, see, I told you, right, this is invalid. This is invalid. Let me take the eraser. This is invalid. Why? Because and is a keyword. Okay, and is a keyword, so we shouldn't use it as an entity name. Okay, we shouldn't use any keywords as an entity name. This is valid. This is valid. This is invalid. Okay, and get and get. Okay, so see, I forgot here the semicolon, right? You should put it. Okay, don't forget it. You should put the semicolon. See, I only forgot the semicolon. You shouldn't forget it. Okay, entity name shouldn't be keyword. Okay, this is the point you should remember. Next, let us see each of these in detail. Okay, yeah, next, where generic declaration. Okay, this is optional. Why? Because always we shouldn't need any constant values in our programming, right? Okay, so that it's an option. Okay, we shouldn't declare, but declaring port class is a mandatory. Why? Because in our design there will be some input and output, right? Without input and output there is no any design, right? So that it's mandatory, whereas generic declaration is optional, so that it is not that much important than compared to port class. Declares constant that can be used. Okay, I already told you, to control the structure or behavior of entity. Okay, yeah, like I already told you examples, right? In the UART we are going to use the part rate 9600, and also if you want to make any design parameters, then you can use this generic declarations. Next, syntax for generic declaration. Okay, these particular generic will be in the entity itself. Okay, I'm going to talk about the entity part. Okay, the VHDL code is consisting of two parts. One is entity and the architecture. Entity represents the what are the inputs, what are the outputs, and also what are the generic constants. And whereas the architecture represents the relation between the inputs and outputs. Okay, in that particular entity, we are going to have the generic declarations, port class, and declarative items. Okay, right? Entity declarative items. In that entity itself, we are going to write the generic declaration syntax like follow. Okay, generic is a keyword. Okay, bracket parenthesis constant name we should give it. Okay, it is an identifier. Subtype indication, you should mention what is the type of the constant. Okay, next, whether it may be the integer or any other type. So bracket colon equal to value, bracket close, semicolon. Okay, this is the syntax. So next, if you have any other, okay, okay, if you are having the more than two variables or three variables, we can declare like this. Okay, you can separate it by the semicolon. Okay, this is one constant variable, and same you can, after putting the semicolon in the parenthesis itself, you can write another uh, constant value. Next, and so on, you can write n number of constants if available, and whereas in the last you should keep the parenthesis closing. Okay, and then you should keep the semicolon. Okay, for the last constant, you shouldn't keep semicolon inside. Okay, you shouldn't keep semicolon inside for the last one. Okay, you shouldn't keep semicolon inside. You should keep only outside after putting the parenthesis, closed parenthesis. Okay, for example, this is the last one. Okay, for example, treat it as a last one. Then you should close the parenthesis and you should use the semicolon after it. You shouldn't write semicolon inside it. Okay, okay, that's the syntax. Okay, so you just remember it. Next, now we have discussed about the generic declaration. Now we are going to discuss about the port class declaration. Okay, generic declaration is an optional. Why? Because I already told you constants, always we shouldn't need any constant values in our program. Whenever it is needed, then we are going to use it, so that it's an optional. We shouldn't declare it. Okay, every time. Entity declaration, where the second part is port class, which is very mandatory. Why? Because what is meant by port? Inputs and outputs of a design are called as the ports. It means port class means we are going to declare those inputs and outputs, specifies the interface channels of entity. Interface channels of entity means entity means for the design, connections from the external design, external designs. Okay, yeah, it means inputs and outputs, right? Next, syntax for the port class. Port is a keyword. Okay, you should use it as keyword. Port name, you should give user defined identifier. It's an identifier, it's a user defined. And mode in the sense whether it is in input or the output mode. You should mention like in comma in for the input, and you should mention out out. Okay, next, subtype indication means what is the type of the port, whether it may be std, logic, bit vector. Okay, it can be anything. So next, similarly, this is one port, it whether it may be the input or the output. Okay, this is for example, if you are going to take the AND gate, it is for example, you are going to take a in and then bit. Okay, we have declared one input port, that is a, which is type of in, mode of in, and subtype indication is bit. Okay, we can similarly declare n number of things. Okay, like this, whether it may be the input or output. There is no any rule like that. You should declare inputs in one port class and you should declare output in another port class. No, there is no any rule like that. You can declare input and output in the single port class. If you are going to have n number of inputs and outputs, then you can declare in the single port class. Okay, using these parentheses. Okay, followed by semicolon. Same rule what I have told for the last port. Okay, in the previous class, for the last generic constant, we shouldn't use semicolon inside the parentheses, right? Okay, remember this point. Okay, we should, for the last port, we simply close the parenthesis, and we will put the semicolon after the parenthesis. Inside the parenthesis, we shouldn't put the semicolon. Okay, next, yeah, we are going to take the example port A, port B, and output is Y. It means we are going to have two inputs and one output port. Okay, how we are going to declare? Port is a keyword and A is the input name, port name, and in, okay, in is the mode of the A, and its type is std logic. It may be the bit or the bit vector. Okay, anything, it can be semicolon. And then B, which is another input port, and then we are going to specify its mode in, and then std logic. Okay, next Y, which is a output, so we specify the out and std logic. You may got and out that, sir, you have used here caps in, and here you are going to use small in. Okay, no problem. Why? Because in VHDL is a case insensitive programming language, so that capital in and small in are both are same. Okay, remember this point. And also I told you, right, for the last port, Okay, you shouldn't mention semicolon after the subtype indication. After closing the parenthesis itself, you should mention the semicolon. Okay. Next, VHDL is case sensitive. This is point you should remember. What is meant by case sensitive means capital A is equal to the small a. Okay, insensitive. Case insensitive. Okay, you should see this in. Okay, it means capital A is equal to small a. Next, second example, A comma B, and you can also declare. Okay, like this. Okay, A and B are both are the inputs. So instead of taking two lines here, you can simply put comma in between them, A comma B in std logic by by colon out std logic. Okay, you can also give like this. Okay, but you shouldn't give like this, A comma B comma y in comma out. You shouldn't give like that. Okay, remember this point. Yeah. Next, last part is entity declarative items. Okay, declare some constants, types or signals that can be used in the implementation of the entity. Okay, it is going to declare some constant like generic constants only, and also it is going to declare some types or signals. Signals means intermediate signals. Okay, intermediate signals we can able to use. Okay, this is also an optional. Next, let us see an example for the adder. Okay. Okay, let me tell you one thing. Now, our VHDL code is consisting of two parts. One is entity and another is architecture. Okay. Till now, what we have learned is the entity part. The entity consists of generic constants. Okay. Generic constant declaration, input output ports declaration, and entity declarative items declaration. Right. Right, in that generic constant is optional, whereas port class is mandatory, and declarative class entity declarative items is also a mandatory. Okay, whereas in the architecture part, what we are going to do, we are going to do write the relationship between the inputs and outputs in it. Okay, it is the part of the entity code. Okay, see, entity is a keyword and is a keyword. Here adder is a user defined name. Okay, adder is a user defined name, you can give it what you want. Okay, and it shouldn't be keyword, and there are some set of rules for specifying the identifier name that we are going to see in the coming videos. And is a keyword, where generic is in that entity. What we are going to have generic declarations, port class declaration, declarative items, right? So in that entity only we are going to take the generic. Okay, generic means declaring the constants. N is a constant, and we are going to use colon, and then we are going to specify the type integer, colon equal to 4, right? And value is 4 and type of integer. Okay, semicolon after m is another constant which is type time, and its value is 10 nanoseconds. We can see that for the last value we are not going to give semicolon immediately after assigning the value. We are putting the parenthesis, closed parenthesis, and then we are going to put the semicolon. You shouldn't forget this. Next, port. Next, this is the part of the generic declaration. So we are going to declare the port class. Okay, port class, in what we are going to do, we are going to declare the inputs and output ports. Okay, we are going to take the adder, right? Full adder, a comma b comma c in. Okay, are the inputs. So I specified that a comma b comma c in, colon in, mode is in, and the type subtype indication is, it may be the std logic, or it can be the bit, or it can be the bit vector. Bit vector means more than one bits, so that we have to use 1 down to 0, or 2 down to 0, 3 down to 0, right, like this. Okay, for multiple bits we are going to use the bit vector. For single uh, bit we are going to use the bit or std logic. Okay, so after putting the semicolon, we are going to, this bracket is for this. Okay, this bracket is for this. We are going to put the semicolon, and we are going to specify the output ports, which are sum comma cout. Okay, both are output, so that we are going to mention the comma in between them. After colon we are going to specify the mode and then std logic, or it may be the bit, or it may be the bit vector. Okay, it can be anything. Okay, we shouldn't write like this. Okay, it can be anything. For example, I'm going to take it as std logic only, so that you shouldn't write this part. Okay, this part you shouldn't write if you are going to take the std logic. Okay, and then end is a keyword, and adder. Why? Because you should give the entity name here, and you must keep the semicolon. Okay, if you are going to have a knowledge of Verilog, then you may forget putting the semicolon after this. Okay, you shouldn't forget like that. So in this code we haven't used any entity declarative items. Okay, because it's an optional. Also the generic part is also an optional. Only the portless is a mandatory, because any design can contain inputs and outputs. Without any input and output, there is no any design in the world, right? Without constant there is a design, it's possible, right? So that this is optional. Okay, this is mandatory. So this is all about the part of entity in the VHDL program. Okay, yeah. Next, yeah, in the coming next video we are going to discuss about the architecture part. Okay, I have completed about the entity part in the VHDL program. Okay, but let me summarize you for you. So the VHDL program is consisting of two parts. One is entity and architecture. Entity is you going to specify the input output, what are the inputs and what are the outputs, any constants. If we are having any generic constants, then we are going to declare those things in the entity. Okay, yeah. For that we have three types in it, or the three in that we are having three parts. Okay, one is generic declaration, which is used to declare the constants. It is an optional. Okay, whenever we require to declare the constant throughout the program, then we are going to use it. And there is port class declaration, in which we are going to declare the both input and output ports what are having to the design. And then the third thing is entity declarative items, in which we are going to declare the intermediate signals types. Okay, some other values. Okay, next, in the coming video we are going to discuss about the architecture. Stay tuned. Thank you.